So the first thing that I want to talk about is this document that I have here. It's called The Do's and Don'ts of Teaching Periodic Trends. And this is actually a document that was given to the AP chemistry teachers about 5 or 6 years ago. Might have been a little longer, I can't remember. But that's when I kind of started to shift into like Coulombic attractions and using that equation, and we talked about it earlier on in the unit. This actually is a good document for you to look at now. It's also a very good document for you to look at in May because periodic trends, or topics 4 and 5, make up 20% of your AP exam in May. 20%, 1/5 of your exam will be over what we're doing in this unit. So hopefully you love this unit. Hopefully, okay? All right, so let me read through some of this, and then I'll go over an example of a do or a don't here. And some of these are like crazy, but it's okay.
I have a question. Is the test still going to be scale adjusted?
I don't know that yet, so we'll see.
Oh, another question. So should I continue to practice the free response questions, or?
We only have like 3 left. I've added 3. We went through all of those.
Yeah,
oh, absolutely, yeah.
Okay.
So the question was just asked, should I keep looking for and practicing free response questions? Oh, yeah. Oh, yeah. Because those concepts, you're still going to have to be able to answer them by choosing the best answer. So what we don't want to do is just say, oh, we're not going to have any free response. I don't need to work on those. Oh, no. You need to stay on that because, again, I'm going to be stealing some questions from quite a few free response questions from many different years and putting them in as multiple choice questions. So if you're like, oh, yeah, I hit the mother lode on 1999, they had this one question that had blah, 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 because the one question I saw that Craig put in there in the test, so I know that those 5 are going to be up. Nope, there's only one part. So I'm actually doing a potpourri for this. So I'm kind of hitting decades of questions with this next test, which is kind of fun.
So should we look at other?
Oh, yeah.
Or just the ones you gave us?
Oh, yeah. If you can find more, yeah. It's all good. And you're going to find out they're duplicating. There's nothing that we haven't talked about yet. They're just rewording it. And I found a couple more that we're going to talk about today. So buckle up. Enjoy the ride. All right, so the do's and don'ts of teaching periodic trends says the AP chemistry test typically addresses periodic trends and free response questions. Students are often given a statement such as, in terms of atomic structure, explain why the first ionization energy of selenium is less than that of bromine. Often these questions are not well answered because students simply state the trend, such as the ionization energy increases as you move left in a period or a row, and fail to address the forces at work that created the trend in the first place. Your first order of business when teaching this unit is to emphasize that students must address the forces that create the trend and avoid the impulse to use the location on the periodic table as an explanation of the observed property. If needed, chant over and over again, a trend is an observation, not an explanation. It is fine to state the trend in their answer, but they must go further by explaining what causes the observed trend. And that's what we've been doing. We've been talking about the trend, but not enough to just stop on your observation. Talk about why. The Coulombic attractions, the effect of nuclear charge, core electrons, valence electrons, etc. We've been doing that already. In other words, what I said back in baby chem about, oh yeah, what's the trend as you move left or right along the periodic table? It gets smaller. And if you had me in baby chem, I said, because the nonmetals want to fill up their 8 valence electrons. That's all I said. And I dropped it at that. And I left it very vague. We didn't explain it then. And then when we came in here, I said, okay, here's why. And we talked about that, numerous reasons. All right, in addition to discussing forces, train your students to mention both of the atoms or ions in a question. And we've been doing that. So when it was talking about this and that, compare both, make sure you include both in your answer. We've been doing that. So make sure that you talk about each if they're asking you about 2 different things. Addressing one and leaving the other implied does not usually earn the point for this type of question. Almost all the properties that are asked about in the exam, questions rely on Coulombic attraction between the outer electrons and the nucleus. Answers to these questions should always include a statement about how the attraction is affected. The concept of Coulomb's law should be taught, and students should be encouraged to mention it in their explanation. Coulomb's law shows that the force of attraction between two oppositely charged particles is directly proportional to the magnitude of the charge, and it's inversely proportional to the distance of those charges. So it's talking about our favorite equation here. So when we, again, just to refresh your memory, as the distance increases, what happens to the force of attraction? It gets weaker or it decreases. If we become more positively charged as an atom or an ion, what happens to the force of attraction? It increases. As a result, the distance decreases. Okay, so those are the things that we've been talking about. So we know what the trend is. Just implement this equation in that. Okay, if you're asked to do the free response. So when you see a multiple choice question, kind of keep that in the back of your mind of what's happening. Okay, go smaller. All right, so here is like the things that they want us to do and don't. This is more for you. So like if you were talking about atomic radii, I'm just going over the first box here. Atomic radii decreases as the atomic number increases in a given period. Don't just say it gets smaller as you move left or right on the don't, but do talk about the effect of nuclear charge, the core electrons, the number of protons increasing within the nucleus as those atoms move left or right. That's what we're talking about in terms of making sure that you're getting the correct and full explanation. All right, so I wanted to share this document. There's quite a few pages on here that you can look at. You don't need me to read through all of these. If you have questions about it tomorrow or tonight when you look at it, bring it up tomorrow when we're talking. Okay, there's a lot of good stuff on here. So the easy way to lose points or not earn points is by answering the question where it says, don't do this, or don't answer it that way. Okay. All right. If you look at topics 4 and 5, I did update the document and I've included some more questions. Also, I included yesterday's video discussion from period 5. I'm actually recording it in this class now for this question. So you guys get to have the video for today. And I also have in that was what, yesterday was Tuesday. So here's Mondays, and then a couple pages there, that's Friday. So those are the updated links if you need to watch those or listen to those again. All right, so let's take a look at this question. And you may need to like redo your CAMI or open up your topic 4 and 5 to be able to view this question. I actually have 3 of them I want to go over today. So if we have time to get through them. Okay, so I'll give you a second here to like look and find that. So it's in the big document. If you go to the proposed schedule and it says at the very top, the Google Doc, that's where this is at, in that big kahuna. It's added to the very bottom. Oh, while you guys are looking for that, let me talk about the information that I have on the very last page. Okay. So this was originally on there, and I made this quite a few years ago as well. What to know for the topics 4 and 5 exam. Okay, what to know. Be able to describe and explain Coulombic attractions. We've done that numerous times in here. Be able to describe and explain effective nuclear charge, also known as ZEF. Be able to correctly draw Lewis dot structures with the correct formal charges, or if it violates the octet rule, make sure we revert to the octet rule. Be sure that you can recognize and draw resonance structures, if applicable there. Looking at correctly drawn Lewis structures and be able to determine the type of intramolecular forces. Those are the forces between what?
Mailbox.
Yay.
You can
Between
tell none of us have been.
between atoms, and intermolecular forces are between molecules. Which one is typically stronger, intra or inter? Good, between the atoms. Excellent. The total number of sigma and pi bonds, the hybridization, and that we'll only ask you about the hybridization of the central atom, or if there's multiple central atoms. In other words, it's a carbon chain. I could ask you that. The bond angle for a certain central atom, the relative bond strengths for single versus double versus triple, and the average of all the bond lengths in a resonance structure. We did that the last couple of days. The polarity of a molecule, whether it's polar or nonpolar, the name of the molecular shape of the molecule, in other words, the Vesper table. Make sure you can read that. If asked, how to draw isomers or recognize isomers, since it's multiple choice. Be able to read a PES data and answer questions associated with that data. You will see that. Be able to describe and explain ionization energies, electronegativities, atomic radii trends, ionic radii, and make sure that you can draw correct electron configurations, understand the difference between paramagnetic, diamagnetic, be able to determine the legal versus illegal quantum numbers. We did that yesterday. And what each quantum number represents. Pretty important. And last but not least, this will be the calculator portion. And yes, you will have a calculator for this on Friday that has wavelength, frequency, and the energy of light. So a lot of good stuff here. And keep in mind that when we get to the AP exam in May, 20% of the material, you're looking right at this page. That is 20% of the AP exam right there. Okay. So the exam will be multiple choice. You'll have all the answers in front of you. So I am in the process of taking some free response questions that we have here. I'll use some of those questions, but I'll give you options to choose the best. There'll be some really obvious, that can't be it.
Are you making it easier?
No, it's not going to be easier. It's going to be fun.
Well, you should make it easier because this is a really hard time for most students. You should cut us some slack.
Yeah, I should. Thank you. I'll keep that in mind.
You're welcome.
I won't put anything on there that I haven't talked about.
You usually do that.
I do. I know. All right, let's look at number 5. So hopefully that's giving you enough time to find it. It says, using the principles of atomic and molecular structure and the information in the table below, answer the following question about atomic, fluorine, oxygen, and xenon, as well as some of their compounds. So you got your first ionization energies for fluorine, oxygen, and a question mark for xenon. Write the equation for the first ionization of atomic fluorine that requires 1,681.0 kilojoules per mole. I'll give you a hint. ATFQ. Write the what? Equation. And some of you are going to go, I seriously can't believe he asked us this. I gave you a whole lot of room to write, too. So somebody tell me, how do I write this equation? F arrow? Is that what you mean? Since it's an equation?
Yeah, sure.
Okay. So what are we doing? Ionization of, what does that mean there? The ionization of atomic fluorine. What are we doing? Adding an electron? Removing an electron. Very good. So if you take an electron away, how does your fluorine look? plus 1? Oh, yes, my bad. So make sure that the charge is at up. And sadly, this is dealing with like electronegativities, which we haven't talked about yet. But it's always nice to see that the -1 + 1 equals neutral.
So if it was oxygen, it would be -2.
Well, for the first one, we're still just taking 1 away. If it asked for the second one, yes. Okay. All right. Letter B. Wasn't that fun? We hadn't got to do something like that. All right. Letter B. Account for the fact that the first ionization energy for atomic fluorine is greater than that for oxygen. Why? Why is fluorine's first ionization energy higher than that of oxygen? Just that easy. Would not hurt to mention the fun equation that we have. So we have more protons in the fluorine than we do with the oxygen. Therefore, the force of attraction is greater because the distance is smaller. Or you could focus on the proton in addition to that. Okay, so it has more protons, therefore the force of attraction, while the core electrons are the same. I like that you guys implemented that. The distance or the atomic distance is smaller, therefore it requires more energy to remove that electron. Okay. C. Predict whether the first ionization energy of atomic xenon is greater than, less than, or equal to the first ionization energy of fluorine. Let's pop a periodic table up here, just in case. Come on now. So the first ionization energy, oh, really can't see that. Go red. So we got fluorine versus xenon. And the question was, nope, we don't want that one anymore. The question was asking, account for the fact that the first ionization, C, predict if the first ionization energy for xenon is greater than, less than, or equal to the first ionization energy of fluorine. So xenon, is it higher, lower, or the same? Ooh, I heard higher and lower. Got a lower. Who's on the lower bandwagon? Who's on the higher? Why higher?
Well, doesn't it has more orbitals, so it's making the radius.
There it is. Look how ginormous xenon is versus how small fluorine is. So in this case, it is true that xenon has far more protons, but what level are we in? Is that the 5th row? Yeah, 5th row versus the 2nd row. So the atomic radius is so much smaller. And when we talk about if we're going to try to make compounds with neon, how successful are you going to be with making a compound with neon? Not at all. Nicole's given the slash the throat, like it ain't going to happen. But xenon, oh yeah, xenon, it's so big it doesn't even realize other atoms are jumping on it and sharing those electrons. So very good on choosing fluorine, or that xenon will have much less ionization energy. And again, you can talk about the radius and the force of attraction for that first electron. Now, I don't know what the ionization energy for xenon's first electron is, but I guarantee you it is a lot lower than fluorine's.
So when you do like the formula, the down arrow would be
So
the radius.
if we were doing this.
No, the radius is bigger.
No, so you're talking about
The distance is
the xenon is bigger, therefore the force of attraction is smaller than that of the fluorine.
And xenon has so many
Orbitals with electrons in them.
Yeah.
Yep,
Okay.
that's awesome. I love it. All right. Letter D. Xenon can react with oxygen and fluorine to form the compounds. There it is. Xenon trioxide and xenon tetrafluoride. In the boxes provided, draw the complete Lewis dot diagram for each of these molecules represented below. Do it. All right. Everybody good?
Are you supposed to? Can you like draw the thingies for the...
Yeah. Now in April we'll talk about what that actually implies, but for now I like it. Okay. All right. On the basis of your Lewis dot diagram you drew in part D, predict the following. The geometric shape for this guy. What is the geometric shape? And keep in mind, we only care about the shape that the atoms form. So what is it? Elaney.
Oh, I feel like it's wrong.
Say it.
Trigonal bipyramidal. No, not bipyramidal.
Trigonal pyramid. Good. You're right. The hybridization for this guy. What is the hybridization? Oh, dang it, go away. What is the hybridization for the xenon tetrafluoride? Hybridization. What's the potential? Let's start there. 6. So you should have how many letters? 6. Same as the potential.
So D2, SP2.
Yeah. Or SP3D2. Tomato, tomato.
Did we get to use our own charts?
No.
Wait, so on a multiple choice, if that was a question,
Uh-huh.
can you put both of those?
Actually, yeah, because say it again.
So like,
No, I won't put both. It'll be one or the other. And I'll be honest with you. I like putting the D first. No, it doesn't matter which way you put it. That's just my preference. But don't be surprised if I mix it up.
So we will use our own charts?
Yeah, you'll have your own table.
What if we would just write a bunch of stuff on it?
Don't do that.
I'm not going to, but like, what if someone else did?
What, Zoe?
Yeah. No, like not me, like someone else in the outfit.
Oh.
You know, like,
Like Zoe
wait,
wrote
but I
on
have
her
stuff
thing.
written down on it. Like I have that.
Okay. All right, letter F.
Okay.
Predict whether the xenon trioxide is polar or nonpolar. So the yellow one here, or the one here, is that polar or nonpolar? Okay, now justify.
Has a lone pair on the side.
It's
Asymmetrical with one lone pair within a trigonal bipyramid or trigonal pyramidal shape. Yeah, excellent. That wasn't so bad.
Wouldn't you say something about
Go ahead.
trigonal pyramidal within a tetrahedron?
That's okay. Just make sure you're saying it's asymmetrical. There's a lone pair, and then one of those two names is fine. So you got a lone pair within the tetrahedron or tetrahedral shape, or that it is asymmetrical within a trigonal pyramidal shape with the lone pair.
Wait, what?
Tell me what you wrote.
I did bullet points.
Okay.
Asymmetrical, one lone pair, and trigonal pyramidal. No, not Pure metal within tetrameter.
Okay.
Why do I keep saying bite? Pure metal.
Because it's so much easier, it rolls off the tongue easier. All right, let's look at this question. And what do we got here?
12.
We might be able to answer a couple more. All right, so here are some ionization energies of element 1, 2, 3, and 4. Intriguing. God, I remember giving this question out. Oh, I used to do this for a practice question. I probably will still do it in May, so you guys, or April, you guys will probably forget about it. But let me read it. 6, it says the table above shows the first 3 ionization energies for atoms of 4 elements from the 3rd period of the periodic table. The elements are numbered randomly. Use the information in the table to answer the following questions. A, which element is most metallic in character, and explain your reasoning. Element 1, 2, 3, or 4? Which one is most metallic? Yeah, what does it mean? Which element is most metallic? I don't know. Is it 1?
Well, if it's the most metallic, then it's going to be on this one. It's going to be harder to remove.
Okay, I agree with that. I totally agree with that. So what Hannah's saying is, if it's going to be metallic, it needs to be over here. Does everybody agree with that? Okay. Oh. So look at the data to find out which element is what Hannah just said. Is it? It is randomly. It says it's randomly ordered.
And then,
I didn't. We're not asking. It's element 1, 2, 3, or 4.
oh.
And again, element 1 could be over on the far right, or it could be on the far left. It could be smack dab in the middle.
So we don't know where these are.
No, not yet.
So don't look at this.
No, don't look at your periodic table. Look at the data. This is all you're looking at right now. So which of these, element 1, element 2, element 3, or element 4, represents the most metallic? Casey, is that your hand up, or are you just messing around? Why do you say 2? How do you know it's in 1A? And then it jumps. There's a big jump from the first to the second. Yeah, there we go. So element 2, so we would answer the question. And then what would be a good justification? Say it again. Sam? Which indicates that the element has 1 valence electron and is located in the very first column, or in the alkali metals. There we go. All right. B. God, I love this question. This is my favorite question of the whole bunch. Identify element 3. I'm telling you, I love this question. Identify element 3. Nicole, this is on your plate, girl. So we're looking for this.
Element 2 has 1 valence electron.
Let me ask you this. How many valence electrons does element 3 have? 2.
I didn't know this.
Because going from here to here, is that a big jump?
No.
Going from here to here, is that a big jump?
Yes.
Yes. So it says that 2 are easy to remove. So that means there's 2 valence electrons. Okay. So now that we know that it's in column 2A, identify the element. Why do you say magnesium?
Because it says it's in
Because
the 3rd period.
A, T, F, Q. This is why it's my most favorite question, because this makes you read the question. The table shows the first three ionization energies of atoms and four elements from the third period. And notice when I read it to you, I kind of like moved right through it, because that's how all of us read these questions. We don't read the question. We don't like grab information that's relevant or important. So magnesium, because it is in the third period or third row, and it has 2 valence electrons. That's it. That's your explanation. Well, yeah, I mean, you talk about the ionization energies. So the first 2 ionization energies are relatively low, while the third has a big jump.
So for these, those aren't big jumps and those aren't big jumps. So how do you know how many valence electrons you have?
Sometimes there's garbage.
So those are like there's no questions about them?
Well, I don't know. Let's see. Letter C, write the complete electron configuration for an atom of element 3. Oh, well, so we're still on element 3. So write the complete electron configuration. So obviously you identified it as magnesium. Now, had you identified anything, like if you identified it as, I don't know, aluminum or arsenic, whatever, as long as you write that electron configuration correctly, you would have got the point for that. So when it says complete, just that easy. Letter D, what is the expected oxidation state for the most common ion of element 2? What does oxidation state mean again? Reflect back to baby chem. What is the oxidation state? You're not going to be happy with yourself. Say again?
I'm okay with not knowing.
Oh, that's an easy point. I may ask it on Friday.
Loss of electrons.
Wait, is it like the most common state is going to form?
So, okay, maybe. So what's the answer? Ooh, you were so close. How many valence electrons does element 2 have? 1. Plus 1. There you go.
So what's oxidation state?
Means the charge when it becomes an ion. The most common charge, that's what oxidation state means. The most common charge that an atom will have when it becomes an ion.
Why would I look it up? It said loss of electrons.
Yeah.
So
What
one.
is the chemical symbol for element number 2? Oh boy. This question's mean, because if you jack up not being able to read third period, whew, yep, sodium.
Wait, so for D, it's just 1.
It's plus 1.
Plus 1.
Yeah. And then letter F, the neutral atom of which of the 4 elements has the smallest radius? Ooh. Eleni, this is your question. Which of these, element 1, element 2, element 3, element 4, when it's neutral, has the smallest radius?
I don't even know what each thing is.
You got this, Eleni.
No, I don't. That's
I believe in you.
I don't.
Well, we can already eliminate which 2. Yeah, we've already been talking about 2 and 3 all day, so those are out.
How do you know that?
Those are metals. Here's your hint. Which one has the largest first ionization energy? Because if it has a large first ionization energy, then the force of attraction is very high. Therefore, the distance is
Very low.
very low. Always revert back to the equation. That equation is your friend. So element 1 has the smallest radius. And what would the justification be? Easier than that.
Has the greatest.
Yes. So we have to talk about the information provided. Sam, you're becoming.
A great chemist.
Yes. Yes. I was going to say rock star, but I don't know if he likes rock. It doesn't explain, but it's always nice to know. All right. That's all we're going to do for today, guys.
We're not doing the other one.